No. No, I really don't think so. No, this unit's the best unit. No, for sure. Oh, hey, didn't see you there. Welcome back. Today we're going to be talking about slope. We're going to use slope to flex on those hater equations. So let's go ahead and get started right now. Welcome back to the function unit. Today we're going to be talking about slope, so let's go ahead and get started with that right now. So in order to begin talking about slope, we need to know what slope is. Slope is the measure of how steep a line is on our graph. It also indicates to us whether a line is positive or negative. So now let's take a look at the 4 ways we can classify slope. So looking at our graphs here, it says we can describe slope in 4 ways. So the way that we're going to do that is we're going to take a look at our graph. We're going to start at the left-hand side and look across and see what way our line is moving. Just like when you are reading a book, you read left to right, same thing here. So in my first graph, I'm starting down at the left-hand side, and as I move to the right, my graph is going up. That means that the slope here is positive. On my next graph, I'm going to start at the left-hand side, and I can notice my line is going down. That means my slope is negative. At the bottom left-hand side there, I can see that my line starts and stays the exact same. It doesn't go up, it doesn't go down, so we're going to classify that as no slope. There's no slope to the line, it's not going up, it's not going down. The last type of slope we have is a vertical line. We'll spend more time talking about this in Algebra 1, but this slope is known as undefined. We can't define it because it's not really going at a slope, it's just going straight up and down. There isn't a definition for that, but we'll cover more of that when we get to Algebra 1. Now let's try and find slope using a table. So here we have a table of values, and we're going to find the slope, and it says the slope is the change in y values divided by the change in x values. Now whenever we're talking about slope in an equation, we define that with the letter m. So anytime you're talking about slope now, or in algebra, or algebra 2, or geometry, slope is always identified as the letter m. So now let's take a look and figure out our change in y's and our change in x to see if we can determine slope. So I'm going to start with our y value since that's going to be at the top. So to get from 8 to 5, I'm going to do that by subtracting 3. To get from 5 to 2, I'm going to be subtracting 3. To get from 2 to negative 1, I'm going to be subtracting 3. And to get from negative 1 to negative 4, I'm going to be subtracting 3. So my change in y values is always negative 3, so that's going to be my change in y values. Now I'm going to figure out my changes in x values. So to get from negative 2 to negative 1, that's an addition of 1. To get from negative 1 to 0, that's an addition of 1. To get from 0 to 1 is an addition of 1. And to get from 1 to 2 is an addition in 1. So my change in x values is positive 1. So now I'm going to simplify my fraction. Negative 3 divided by positive 1 is going to give me negative 3. So the slope of our table here is negative 3, or m equals negative 3. Now let's take a look at how to find slope on a graph. So here we are with a few graphs, and we're going to try and find the slope of them. But remember, slope measures how steep the line is, also known as rate of change. So we can describe the steepness when we're talking about slope, we call it slope, as rise over run. So how much does the line rise over how much does it run horizontally? So in order to figure this out, we're going to start at the y-intercept. And the y-intercept is the place where the line crosses the y-axis. So looking at the first one there, I'm going to start at where the line crosses the y-axis, which is here at negative 4. Then I'm going to figure out the rise, how much it goes up, by the run, how much it goes sideways. And we're going to try and do this by integer coordinates. So we're not going to try and stop at a point in the middle. So I'm going to start by going up 1, up 2, up 3, and then I can see that I need to go 1 space over, and I'll be back at an integer coordinate. So I went up 3 spaces and over 1 space, so my slope is 3. Now if I'm not sure, I can keep going. So I can go up 1, 2, 3, over 1, up 1, 2, 3 over 1. And I can see that my slope is up 3 over 1 the entire length of the line. So if I'm not sure, I could just keep going and check my work. All right, now let's take a look at the second one there. Again, I'm going to go to the y-intercept. That's where I'm going to start. You can start at any point on the line. It doesn't have to be the y-intercept, but it's a good rule of thumb to start at the y-intercept just so you know where to start every time. So now we're going to go up. I'm going to go up 1, and if I go over, it doesn't look like any of those points, and the line is going to cross at any of those points at an integer, so I'm going to keep going. Up 2, and then I'm going to see that, yes, if I go over, I'm going to get to an integer point if I go over 1, 2, 3, 4, 5. Yep, that works. And I can check it going the other direction. So over 1, or down 1, 2, over 1, 2, 3, 4, 5. And yep, so my slope here is going to be up 2 over 5, or 2/5. This fraction can't be reduced, so that is my slope. Now, looking at my lines, the first two, if I look from left to right, the lines were going up, so my slope was going to be positive. Now looking at the third one here, if I look left to right, then I know that my slope is going down. So I know my slope is going to be negative. So I can start by putting a negative symbol right here. I know my slope is going to be negative. Let's go to the y-intercept, and this time it's going to be at the origin, or 0, 0. And now I'm going to see if I can go up or down. It doesn't matter because I already know my slope is going to be negative. So I'm going to go down, 1, no, can't go over and find an integer point. 2, no, can't go over, find an integer point. 3, yes, I can find an integer point if I go over 1, 2. So now let's check it to see if I've got it right. So I'm going to go down 1, 2, 3 over 1, 2. Yes. And I can check going the other direction. Up 1, 2, 3 over 1, 2. Yes, it works. Up 1, 2, 3 over 1, 2. Yes, it works. So my slope is going to be negative 3 over 2. Now let's take a look at you trying some of this on your own. So here we've got 3 practice problems for yourself. It says find the slope of each line. So I want you to take a minute, pause the video, try these 3 on your own, then press play again to see if you are right. How did you do? Did you get the same answers that I did? Hopefully if you did. If not, go ahead and erase your work and make sure that it looks like mine. And let's move on to the last slide. So here we've got a couple challenge problems that they want us to try. The first one wants us to draw a line that passes through -5, -4, and has a slope of 1/2. So we're going to start by doing that by picking the point that they've told us, -5, -4. So we're going to go over -5, down to -4, and put a point there. Now we need to have a slope of 1/2. So we know it's going to go up 1 over 2. So since I know the slope, I can go ahead and just count and make my points and then connect the line. So I'm going to go up 1 over 1, 2, make a point. 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 And as you can see, I've started to make a line, and now I can connect my points using a straight edge. And I'm going to go all the way through my graph and draw arrows on the end, so I've completed that one. The next problem says draw a line that has a y-intercept of 5 and a slope of -3. So the key here is knowing the y-intercept, because the y-intercept tells us where it's going to cross that y-axis. In this case, it's going to be 5. So I know that I can start here at 5, and I've got a slope of -3. That means I'm going to be going down and to the right. So I'm going to be counting spaces again with a slope of -3. That's the same as -3 over 1. So I'm going to be going down 3 and over 1. So down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. And now I can see that I've got my points. I'm going to connect them using a straight edge or a ruler. And use my arrows. It's going to go all the way through the graph, and we are done with that problem as well. So that brings us to the end of this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.